In this video, I'm going to talk about spheres, and it's all in my book, Ellen's Guide to Perspective on Amazon. Since a circle is a two-dimensional shape, how can we show a sphere as three-dimensional? It still looks flat even if we put it in a box. So instead, we could cut it in half so we see the inside and outside. We could shade it. We could show texture, or I bet you can't stand the suspense. Show its elliptical substructure. To draw a sphere in a box, you really need to add ellipses suggesting different planes. And the easiest ones to add are horizontal ellipses and vertical ellipses because they touch the midpoints of the sides of the box. Then add a circle, like this red one, that touches the four midpoints. You may have to cheat a little bit because a compass-drawn circle may not fit perfectly. But this gray circle may look more realistic because the sphere hides two of the green dots from our view. So if we're looking down like this, we would not see the bottom of this sphere or the left side. You could use three planes traveling either horizontally, vertically, or towards the distance, all perpendicular to each other. And to draw these planes, you find the midpoints of the edges of the box and connect them together. Then you insert the ellipses, and they all have different degrees of roundness. The magenta ellipse is the outline for the overall shape. Then choose one side for this green ellipse and this blue ellipse so that you can make it look 3D. And there are four combinations that you could use suggesting different viewpoints. For example, this one looks like we're looking at this ball from the upper left, whereas this one looks like we're looking up at it from the lower left. The contour lines always curve away from the eye. A similar approach can be used to draw an egg, except that the vertical plane is moved toward one end of the form. And in this case, the contour line identifies the terminator with the reflected light below it. These contour lines then indicate that the form is round and 3D. It shows the viewpoint, which is here a bird's eye view, and it's useful if there are markings on the ball, and it helps us with shading. As I said, this is underneath this is the reflected light, and this is the terminator. Another example of an elliptical substructure is a beach ball. To draw it, divide a circle into sixths and use each one of these lines as a major axis of the three ellipses here. And make the ellipses different degrees of roundness to suggest that they're on different planes. They all intersect at these two black dots, which are the north and south poles of the beach ball. And each ellipse touches this circle twice. One pole will be visible. I chose this one to be visible, and one will be hidden. So this one will be hidden. And as a result, the lines on the ellipses here are visible, and then the ones back here are hidden. So this divides each pole into 6 parts. And then color the beach ball to emphasize the lines in front so we know which parts are seen and which are not. To find longitudes on a globe, place a circle and the globe so their ends touch these same white vertical lines. Divide the circle into even parts and drop vertical lines down from the magenta dots down to the globe. And where these lines hit the equator, mark the beginning of each one of these longitudinal lines. And they're wider in the middle and narrower towards the edges. For a cross-section, continue the longitudes from the yellow dots toward the center of the ellipse. For latitudes, place a circle to one side of the sphere and divide it into equal parts, and then transfer that level over to the sphere so we know where each one of these horizontal ellipses begin. This is the final globe with both longitudes and latitudes. Here, I enclosed the ellipses in boxes so I could determine their widths, and as a result, the blue ellipse is slightly wider than the yellow ellipse. To decorate this Christmas ornament, drop lines down to identify points on the equator, and the ornaments lie between these two ellipses. A torus is a ring shape generated by bending a cylinder around a point until the two ends meet. An example would be a donut, a bagel, or an inflatable tube. When it's parallel to the picture plane, it has two concentric ellipses. In a 3/4 view, which best shows its form, the middle has two arcs meeting at the pointy ends, which I show with green arrows here. And from the side, the torus has half circles on either end, and the center enlarges because it's the closest part. When rounding corners of a rectangle, the far corners are flatter than the ones nearby. So use ellipses that are narrower in the back than in the front, and their axes lie on these converging lines. All the corners are formed by a quarter of a circle. To draw this wheelbarrow, start with a series of lines here. Add the circle for the wheel and an ellipse for the front. It's a horizontal ellipse, and it looks rounder in the front than in the back. Let's look at the shapes of some of these flowers. So the ellipse here, the little one, is toward the front of the big one, suggesting that it's part of a deeper concave structure. These petals narrow as they move away from the front. These contour lines help us understand the form. This minor axis of the ellipse lines up with the axis of the stem. Now these front petals here are shorter, but about as wide as the petals on the side, and they obscure the center of the flower. A common mistake is to draw only the sides of the flower or a tree, since foreshortening can be scary. But the front is the part that best expresses depth, and petals and branches are distributed equally around a stem or a trunk. To put my picture into a curved grid, I divided the original into a grid with horizontal and vertical lines. Then I constructed the new grid and transferred each square to the corresponding square on the new grid. This changes the emphasis, since the area in front is now larger than the areas on the side, and it gives the picture more of an enclosed feeling. In my next video, I'll give you some tips about drawing round forms, and please remember to subscribe.